When you think ancient Roman concrete, you probably think of the Pantheon, that remarkable dome in Rome with its oculus window to the heavens. But how did they get that concrete up there? They didn't use ready mix. In fact, their techniques are still a mystery to modern science. What we do know is that the Romans used a special kind of concrete made from volcanic ash, known as opus, which mixed with lime and water creates a hydraulic binder that hardens underwater. When cracks form, it actually gets stronger. The Romans also figured out how to create quicklime clasts by hot mixing lime and pozzolana before adding water. This may seem counterintuitive, but by adding water to a hot mix, they were able to create an autogenous self-healing mechanism. That means when cracks formed in the concrete, those lime clasts would dissolve and reprecipitate, effectively sealing the cracks. Now, while this technology was lost for centuries, scientists are just now understanding how the Romans used it, and it's all thanks to this little cube. This is a 2,000-year-old sample taken from the Pantheon dome. It's amazing to think that we can learn so much about the Romans from such a tiny piece. First things first, let's take a look at what's inside this concrete. We can see a bunch of different materials like tuff, brick rubble, and ceramic tile. All these bits of debris are called aggregate. They make up about 75% of the volume of this concrete. The remaining 25% is the binder phase, which contains several different minerals. But what's really interesting is that we can actually see evidence of the hot mixing process in this sample. You see, when the lime and pozzolana were mixed together before adding water, they generated heat. The hot mixing created these healed cracks in a sample, allowing for the formation of larger crystals. These crystals, called aluminous tobamorite and philipsite, act like reinforcements, strengthening the matrix around them. Over time, they grow larger, helping the concrete to become more durable. The aggregate in this concrete also played an important role in its durability. The combination of tuff, brick rubble, and ceramic tile created an interlocking structure that reduced the amount of space between the particles. Less space or porosity means fewer cracks and greater strength. But there's another secret ingredient here: seawater. You see, the Pantheon is a marine structure. It sits right on the coast of Rome. The seawater reacts with the concrete, driving the growth of additional secondary minerals. These new minerals help to densify the concrete and make it even stronger over time. But perhaps the most amazing thing about this concrete is that it's still standing after 2,000 years. That's because the lime clasts that we talked about earlier continued to dissolve and reprecipitate, sealing any micro cracks that form in the concrete. This process is called autogenous healing. It's like the concrete has a built-in repair mechanism that can sustain it for millennia. The Romans weren't the only ones who knew how to make special concrete. The ancient Greeks used a similar technique to build the dome of the Temple of Apollo, and in Caesarea Harbor in Israel, the builders used a tailored binder recipe for the subtidal zone and the above water zone. They knew that the concrete wouldn't be exposed to air and water in the subtidal zone, so they could use a higher percentage of lime. But in the above water zone, they used more pozzolana to resist the effects of wave action. These ancient building techniques are not just fascinating, they're also highly sustainable. The aggregates used in Roman concrete were often waste products from other industries like brickmaking, and instead of discarding them, the Romans found a way to reuse them in a new product. Today, engineers are experimenting with creating their own Roman-inspired concretes. By adding ground granulated blast furnace slag to a cement mix, they are able to reduce CO emissions by up to 60%. And by incorporating crushed glass or plastic waste into the mix, they can improve the concrete's strength and durability. Some researchers are even trying to replicate the self-healing properties of Roman concrete by adding bacteria to the mix. When the concrete cracks, the bacteria would then migrate to the crack and produce calcium, which would fill the crack and prevent it from spreading. Who knows? Maybe in the future, we'll be using Roman-inspired concrete to build our own sustainable cities. But for now, we can marvel at the ingenuity of the Romans and the mysteries that their concrete still holds. Speaking of mysteries, how did the Romans invent concrete in the first place? To find out, check out this video where we explore the origins of concrete. Thanks for watching.